Okay, so the pressure, this is the pressure of a fixed mass of gas is 760 millimeter mercury when the volume of the gas is 3.0 cm cube. Find the pressure of the gas when its volume is 4.5 cm cube, assuming the temperature is constant. So temperature being constant, this means that we are dealing with Boyle's law. If temperature is constant, it means we are dealing with Boyle's law. So in solution, we are going to have the P1, our P1 is equals to 760 millimeter mercury. Our P2 is equals to 3.0 cm cube. Our V2 is equals to 4.5. Then our P2 is equals to dash, we don't know it. So P1 V1 is equals to P2 V2. So P2 is equals to P1 V1 all over V2, which is equals to 960 times 3.0 all over 4.5 equals to 640 millimeter mercury. So this is the increase in, this is the pressure when the volume is what increased. Now when the volume is increased, the pressure reduces, and what we are dealing with what is Boyle's law. When the volume of a gas increases, the temperature is, so when the volume increases, the pressure is supposed to reduce, and the temperature should be what? Constant. If the temperature is not constant, it might not become the same thing, because temperature also affects pressure and temperature also affects volume. So if the temperature is not constant, then we are making a very wrong calculation. Another thing that is going to be very important, like I said before, I've already explained it in the other class, but I also want to explain it here, is the graphical representation of gas laws. Now each particular law in gas law has their own very graphical representation, and this is what you must know. You have to know it by the statement or by the law quote. When they quote the law, this is how you know it. Now questions like this comes out in exam every year, the university tertiary matriculation exams, and then the West African examination. It comes out almost all the time, and then every student that should be good in chemistry should understand that this is a very important aspect of chemistry he or she should know. The graphical representation of gas laws. First of all, we'll talk about the Boyle's law. We are discussing Boyle's law, and the graphical representation of Boyle's law state that the volume is, look at the volume, look at the pressure, but this is going in direct proportion because we have 1 over P. So the inverse of pressure is going to go in a constant. The constant here is equals to what? Our temperature. So this is another one. If the case is reversed, that pressure is here and the volume 1 over V is here, the line should go straight. Now I want you to notice something very unique about this thing. This is 1 over P, not P. This is the inverse of pressure, and that is why this line is going constantly in the positive direction. So this is the inverse of volume, and this is why it is going in the increasing direction, the constant. So the next one is, when this one increases, this one is supposed to what? Reduce. When this one reduces, this one is supposed to increase. And this is how the graphical representation of, this is how Boyle's law is represented graphically.